Good evening, all of you. Welcome, you guys. Welcome, you all. Welcome to the Unacademy. Welcome to the Kreatryx. So, how you are doing, everybody? कैसे हो सभी लोग? I hope all of you are doing great and all. So, chalo, let's continue our discussions. Chalo, let's start our discussions, all of you. And see the previous class, last class, we have discussed about some of the problems on the digital. हमने शुरू किया. Let's continue our discussions. And before this, we have one great news for you fellows. Unacademy, so the rank predictor is working very greatly. So you fellows can able to check your rank with the official keys. Go scan the code here. You can copy your response sheet. You will get your rank. And another great news, we are coming to offline. We are coming to offline in New Delhi. You can find the top educators will take the classes in the offline platforms. And we are providing the great discounts. You can see the 50% of discount for the students who already taken the plus subscription or the iconic subscriptions, and 50% for the student who have joined in the other institutes already. Next, these are the classroom link. So here, if you have any further queries and all, you can check it. Sony Brahmastra EMFT. So here, and so that we have completed for the 2023 GATE के लिए हमने complete किया, and 2024 के लिए soon we are going to launch it. For 2024 के लिए fresh course we are going to launch it soon. Okay, you do follow me. So soon we can launch the fresh course. We can launch for 2024 के लिए. And another new thing here, we are providing exclusively 2 subjects subscription also, that is engineering, mathematics and aptitude. In this session we are planning in this exclusive course, and I am taking the engineering mathematics, and Saurabh sir will take the aptitude. And you can, if you want to enroll for it, you can enroll for this thing just to 4999. And by using the referral code of my promo code BV Reddy, you will get the additional discount भी आपको मिलने वाला, and the great guidance from me, right? And these are the new batches we have started, and you can find the top educators team. You can see here, and I am starting the EMFT in the plus course, that is batch E, and for 2024 के लिए. And so you can find here we are starting. Yes, 7 PM Sujesh has started the signals course, and you can see now this is for EC and electrical. You can find the educators. These are the educators who will take the classes. Have a look at the top educating team you can find, and this batch is for all type of exams. And these are the features of plus center features, iconic, plus as well as a light features. Chalo, let's continue our discussions, all of you. Now in the last class you can see how many problems we have completed. You see, last class I think so we have completed how many, all these problems we have completed yesterday. Previous class हमने complete किया everybody. Now see this thing, how many, 140 completed. Yes, up to 140 we have completed. All of you tell me, up to 140 we have completed. So chalo, let's continue today the remaining problems. And take the next problem, 141. 141. Which are the following is not a valid identity? Which of the following is not a valid identity? Yeah, tell me now here option A check किया तो क्या होगा, tell me. So here we have x xr y xr z. As we know, this XOR gate will obey associative law. XOR gate obeys associative law. So I can write this thing as what, tell me, X XOR Y XOR Z. All of you, since XOR gate obeys associative law, so this identity is the correct type. Now you see the option B, X XOR Y, and which is equal to what we can say, this is complement of x nar, I can write, tell me, and which is given as what now, x nar, which is given as x bar y bar plus xy whole bar. Fine, so that means option B is the sahi na. Let us see option C now here. Look at how this is x plus y xr with z, which is given as what, to tell me, if we simplify it will becomes x xr z plus what, y xr z, isn't it? But लेकिन option C में कुछ अलग दिया ना LHS में here, so this is not correct, you tell me. Right. Next option D, x xr y, and which is equal to what? So we'll get this thing as what now here, POS form. How we can write, tell me, x bar plus y bar into x plus y, and which is given as xy whole bar. Xy whole bar into x plus y, I can say. They has given xy is equal to 0. That means if xy is equal to 0, what is this xy bar, you tell me, which is equal to 1. So then it will becomes 1 into x plus y. All of you boliye. So ye bhi sahi na, tell me. So which is the incorrect option, tell me. Option C. Option C. What is the difference between the paid course and YouTube course? And in case of a plus course, that is a paid course, everything which is available in a structured form, all the classes are available in the one sequence form. And YouTube class, only thing is, if we have a little patience to search the all the things, you can manage with the YouTube classes. Okay, otherwise whatever the content we are discussing in the YouTube and the paid course, both are same. Only thing is, so you in the YouTube, so the course is not in a proper structured manner. If you can able to search in a properly, then fine, you can enjoy this YouTube course also, you can able to enjoy. Fine. Now tell me the next problem. Yes, here in the last class we have seen so many in the waveform problems. Now again we should do the one more waveform problem they given. Right, see this thing here. Consider following circuit composed. They given the circuit now here A and B. They given A value given, they ask him to find the output. So here you see what they are saying is how many transitions occurs at B during the interval from 0 to 10 nanoseconds. How many transitions can happens, right? And if you see this thing here, this input is A, and this is what you tell me, buffer or inverter. First of all, what is this thing, is it is a buffer or inverter? This is a buffer. Fine. So this input directly will go to here A. Fine. And but this will be delayed by some 2 nanoseconds, and I'm calling this thing as, let us call this, I'm calling it as y1. and this output I am calling this thing as a y2, and this y2 is a direct input here, and this is an indirect input, this is a y3. All of you tell me now. And so here you see this thing XOR gate delay. So we don't have any delay for XOR gate. XOR gate does not have any delays, right? Who has a delays? Only the buffers will have a delays. Now say they given the A. Look at now here, A they given us like this. This is my A. From 0 onwards, A value 1, isn't it? Here this is what now here 0. Now tell me now what is a y1? Y1 is same as a, but it was delayed by how many? 2 nanoseconds delayed. So that's why what happens now here, y1 it should be same as a, but it was delayed by 2 nanoseconds. ऐसा होगा ना, tell me. This is my y1. So here at this location we have a 0, at this location we have a 2 nanoseconds. Next, whatever the y2 tell me, y2 is a XOR between A and y1. So when the output of XOR gate is 1, equal inputs or unequal inputs? Unequal inputs, output is 1. So you see this thing here, from here to here, so both are 0, and in this region, so you see this is 0 and this is 1 now, tell me. So output, which is what I can say from here, 0 to 2, in between 0 to 2, output is 1, and thereafter output will become 0 now, tell me. This is my y2, all of you. Now so since this XOR gate does not have any delay, you see XOR gate does not have any delay, XOR gate delay is 0, right? So this is 0 and this is 2. Next, whatever the y3 you tell me, what about this y3 you tell me? And y3 is a delayed version of y2. How much delay you tell me? 2 nanoseconds. So here it becomes like this now, tell me, delayed version. So it will becomes 2 to 4 hoga na, tell me, right? So this is my y3. Here we have 0 and this is 2 and this is 4. Done everybody? This is my y3. Next, final output B output. Tell me B output is what now here? And this XOR gate delay also 0 nanoseconds. When the output of XOR gate is 1, for equal or unequal inputs? Unequal inputs. You see this thing here? Now in this region from 0 to 2, this is 1. And from 2 to 4, this is 1, this is 0 now, tell me, 2 to 4, isn't it? So the output of the B you tell me. So the B output, how it is you tell me. So no delay, from 0 to 2, yes, what you tell me now here? Yes. So this delay given us 4 nanoseconds, sorry. This delay, how much they given? It is not 2 now. This delay is a 4 nanoseconds is given, right? So that means if we add this 4 nanoseconds, how this y3 value tell me? It will become in between 4 to 6 hoga na, and this is 4 to 6, isn't it? Right. Now you tell me now here how the output now here. Between 0 to 2 output is 1, and what else you tell me now? Again 2 to 4 is 0, again 4 to 6 output is 1, again 4 to 6 output is 1, isn't it? All of you tell me. So this is 0 and this is 2, this is 4 and this is 6. You tell me now here. So then after that output is continuously it is 0 only, isn't it? Now you see what they are asking now here. How many transitions? Transition means change from where to where? From 0 to 10 seconds, how many times the output is changing, you have to see. Look at now here at this location 0, it is changing or not? 0 to 1, one time transition. इधर आने के बाद again here it is changing ना, it is changing or not? Another transition. Next here this is, it is changing here, and here it is one more time changing or not? Totally how many times my output will changing, you tell me. कितनी बार change होगा, you tell me. So here totally how many times now? 4 times is changing ना. So कौन सा option tell me? So कौन सा option tell me? Option D. Everybody, all of you, it's a very good problem. Next one. Yeah, take this thing here. For a digital circuit having four inputs, 0 is given as like this, they given like this, okay, and 1 is given as 0 0 1, 9 is given as like this, okay. A combination circuit is to be designed which takes these 4 bits as input and output is 1. When the output is 1, if the number is greater than 5, output is 1 if the number is greater than 5 and otherwise 0. If only and or not gates may be used, what is the minimum number of gates required? Fine, all of you understood the problem. First of all, what they are saying is a logic gate they are saying. So what they are saying is, now here the output is 1 only when the input is greater than or equal to 5. Yes. Now they are using the numbers up to where you tell me? Only 9 only. They are saying the output is what now? Up to 9 only. So as we know, whenever the output is 1, we can call that as a minterms. Yes. To tell me the minterms now, agar maine inputs ko A, B, C, D, let us say 4 inputs we have taken now. A, B, C, D if we have taken, can you tell me the minterms here? So if the output is greater than 5, the output is 1. So output means what we can say minterms are, tell me here. So 5 is a minterm, 6 is a minterm, 7 is a minterm, 8 is a minterm, 9 is a minterm. Yes sir, now all these are the minterms greater than 5 now. And the condition is they are using up to 9 only. They are using up to 9. But lekin by using the ABCD 4 variables, yes, we have how many combinations are possible? Up to 15 tak we can use it. Up to 15 tak is possible, but we have used only up to 9 only. That means whatever the remaining things you tell me, the remaining things are don't cares. Remaining things are what you tell me? Those are the don't cares. This is a crucial thing in this case. Is this point understood? Tell me here. Is this point understood? You tell me. तो इसमें कोई डाउट हुआ तो पूछो जल्दी फटाफट. So this, in this case, the function which is using only up to 9 only. But lekin, so we have, if I have taken the 4 variables, 4 inputs we have taken, what happens now? Up to 15 tak is possible minterms. Those are called as what we can say here. The full course is not available in YouTube. So here in the special classes, my full course is available. Rahul, special classes, my full course is available. Okay, in the YouTube I am doing the problem discussion sessions. You can see this is the 6th class and I am planning to discuss each complete all variety of problems in the YouTube completely. This playlist is available. You can do follow this course for the problem discussions. Right. So now let us minimize it now here. So let us minimize it now here. For minimization, since we have a don't cares also there, we'll go for the K maps. No, now it is not that feature now, that 1 hour access is removed now, I think so. 1 hour access removed, isn't it? Now you can access full time, you can access here. 1 hour access that was earlier. Now that restriction is removed. Now I think we don't have that type of restriction. A B C D. Yes, tell me now here. A bar, B bar. A bar, B. A B. A B bar. Next tell me now C bar, D bar. C bar, D. C D. C D bar. And you tell me the min terms here. So here, as you might know the numberings now here, 5. Here is a 5 now, tell me. 5, 6, 7, 8, 9. Isn't it? And 10, 11, 12, 13, 14, 15. These are don't case. You tell me. Now let's try to group them here. Yes. Yeah, this digital course will be very much helpful. Right. So I can group it now here. So by grouping this thing, what I will get now here? हमको ये मिलेगा. Right. Thereafter, so you tell me now, do you have any quad is possible इसके बाद? Do we have any quad is possible? I think no, isn't it? So what we can do here? Any quad we can do, tell me. So I can do this quad is possible or not, tell me. So a quad से हमको क्या मिलेगा बोलिए ना इधर, which is equal to B and C. Right. So any other quad is possible, tell me. And this quad I can do. This quad we can do here. So tell me what I will get now here. So this is B D. All of you tell me. Done. Now see this thing here. Now what is the minimized expression, you tell me now finally. So which we have A plus BC plus what now here, BD. A plus BC plus BD. So you tell me now how many gates required. What's the minimum number of gates required, you tell me here. How many minimum number of gates required? How many number of minimum gates required for this thing, tell me. Jaldi boliye. Minimum number of gates. Did they mention the number of inputs can take? Did they mention only these gates? They didn't mention about the number, how many inputs these gates can take. So I can take this as an AND gate. So this is my BC आएगा. Yes or no? इधर हमको BC मिला. Now if I use then BD, so I will get here it is a BD मिलेगा. Right. So what else I can do here? Now these things all, this is my A, and here if I assume that I can use any number of inputs, 3 inputs also I can use, then I can take this one OR gate na here. So then we'll get this expression मिलेगा ना इधर बोलिए. So here we have assumed that they didn't mention about what are the number of inputs I can take now here. So you can take the whatever the number of inputs required, you can take maximum, you can accept it. So how many now here? 3. All of you. Next one. Tell me. What is the minimum number of 2 input? In this case they mention a 2 input NOR gate. So in this case we have to strictly use a NOR gate can accept only 2 inputs only. Fine. Now tell me now the expression which is given as, tell me here. It is given as AB plus C. As I told, whenever you want to implement the expression by using NOR gates, the given expression must be in what form here? POS form. The given expression must be in what form here? POS form में होना पड़ेगा. So this is SOP form. Now basically this expression which is in what form is SOP form. इसको हमने POS form में convert करना पड़ेगा. So for this what I can do here, I can use a mingle property. So then it will becomes A plus C into B plus C. Now you see this thing here. This is now POS form. Now by using the mingle property, tell me. This is now POS form here. Now so let us use a NOR gates. Tell me what I can do here. Now we can use what now? Double complement method now. What we can use? Double complement method. डबल का मीटा. यस, कितने लोगों को डबल का मीटा पसंद आई? हाउ मेनी ऑफ यू लाइक द डबल का मीटा? डबल का मीटा पता ही पहले आपको एक हैदराबाद का बहुत अच्छा स्वीट आई, एक बहुत फेमस स्वीट आई. दिस इज A plus C bar plus what? B plus C bar whole bar. कुर्बानी का मीठा. कुर्बानी का मीठा भी अच्छा है. सो यू टेल मी नाउ हियर, इसके लिए वी रिक्वायर्ड वन नॉर गेट चाहिए ना. इसके लिए वन नॉर गेट, इसके लिए और एक नॉर गेट, एंड पूरा के लिए और एक नॉर गेट ना. हियर whole case we require one more. So that means how many NOR gates are required together? You tell me finally. How many NOR gates are required? 3 NOR gates are required. Tell me. Isn't it? And a whole के लिए और एक NOR gate. And this is whole के लिए तीसरा NOR gate. All of you. चलो. Next. The sum of product form can be realized by using, yes, what? Sum of the product. That means what now here? SOP. SOP we can realize by using what? To tell me. किसे होगा? Tell me. It is easy for what now here? SOP form है तो we can implement by using the and or से होगा. Even we can implement by using NAND and NAND से भी होगा ना. All of you. So option C. Both. Isn't it? Next. Now see this thing here. Given a combinational network with 3 inputs A, B, C, 3 intermediate outputs P, Q, R they has taken. Right. They given that X is equal to P into Q. X is equal to what? P into Q. This is P and this is Q. Right. And Y is equal to P into R. This is P, this is R. They given the min terms like this. As shown below, find the smallest function P. Okay, we need to find the P min terms we need to get. या बोलिए ना इधर. Did they given the Q min terms दिया कि नहीं? बोलो. Q min terms भी नहीं दिया. Fine. Now you see this thing here. This is what gate? You tell me. This is a AND gate. You tell me now here. These are the min terms. Means so this must be P में भी होना पड़ेगा. 0 2 4 definitely we need to have a. Now tell me. AND gate. So it should definitely contains 0 2 4. इसके साथ और कुछ भी extra भी होगा. When this is now here, tell me. Yes, try to understand the AND gate functioning basically. Now, if I given this as a 1 2 3 4 6 7, let us say these are the min terms I given. If I given here 2 7, if I given, what is the output min terms? You tell me. What I'll get the output min terms are. That means which are common in both input, that will come as a output now. AND gate means what now here? Product intersection. AND gate is what now here? Product intersection. Yes or no? Intersection will come. And the common minterms in both inputs will come now, which are common here. That is 2 and 7. So that will come as my output. Hana, boliye. Now you see this thing here, output, I know this thing here. That means input may definitely both P and Q should contains all these terms. Then only output वो आएगा ना. इसका साथ और कुछ एक्स्ट्रा भी होगा, but this must be definitely should contain. Yes or no? So this must be definitely contains. इसका साथ कुछ एक्स्ट्रा भी होगा. Right. Next here they given this as 1 2 4 6. That means 1 2 4 6 I तो either A input may be definitely we should contain 1 2 4 6 भी जरूर होना पड़ेगा. So that means ये दोनों मिला के इसके साथ. So finally can you conclude what should be the minterms of P? Tell me. 0 must be present, 1 must be present, and 2 must be present, 4 and 6 must be. This must be present, you tell me. This must be present, you tell me. All of you. Right. तभी हमको x will come, y will come, isn't it? So कौन सा ऑप्शन होगा? Tell me. ऑप्शन B. ऑप्शन B बोलिए. समझ गया कि नहीं? कोई डाउट हुआ क्या इसमें? आना बोलिए. यार आया कि नहीं आपको? चलो next one. What is the maximum number of different Boolean functions involving n Boolean variables? N Boolean variables. Tell me the number of Boolean functions are how many? Number of Boolean functions. The number of Boolean function which is given as 2 power n. Number of Boolean functions 2 power n. So the option C. Next. Now tell me now here. The number of self-dual functions. The number of self-dual functions. The number of self-dual functions are how many? Tell me. 2 power n minus 1. 2 power n minus 1. So this is 2 power n is a functions. 2 power n minus 1 is a number of self-dual functions. Option D. Okay. And so इसका प्रूफ भी हमने किया ना. Next. The SOP form of a logic expression is most suitable for designing logic gates using only SOP form which is suitable by using which gates now here? NAND gates होगा कि नहीं? SOP expressions are easy to design by using which gates? NAND gates. And so here will it be possible with this AND gates only? No. AND gate के साथ OR gates also required, isn't it? That's why NAND is a more correct. And SOP form, POS form means what now? NOR gate. They given SOP form now, that's why NAND gate. SOP form, that's why NAND gate. Right. Now tell me. They given the expression now A is MSB, B is LSB they given, where the inputs are given the equivalent minimized expressions. equivalent minimized form. So these are the min terms they given, but if you see the options now, all are in the POS form, isn't it? So we need to analyze this thing by using POS form में analyze करना पड़ेगा. Let us use a K map. We are using the K map. Use a K map. So this is A, B and C, D. In K map we are using the POS form now. So what I can say, this is A plus B. That is A plus B bar, A bar plus B bar, A bar plus B, C plus D, C plus D bar, C bar plus D bar, C bar plus D. Now see the min terms what they given. 0 is a min term, 0, 1, 3 means 2 is a max term. Where is a 2 here? Here is a 2 now. Next, yes, now here 2, 3, 4, 5, 6, 7 is a min term. Next 8, 9, 10, 11, 12, 13, 14, 15. Check it all of you. These are the max terms now. Tell me. These are the max terms you see. हमने सही मार्क किया, एक बार चेक करके बोलिए. Right. Now let's see this thing here. What we can do. The minimizations हम देखना पड़ेगा. So yeah, बोलिए now what we can do here. Any quad is possible here. Right. So I can do this quad is I can do now. Tell me. Right. So इससे हमको क्या मिलेगा बोलिए. C bar plus D. So here check for एक किधर में होगा. You can see this all the options contain this thing. This is not. We can eliminate now here. Next what else you tell me now. I can do this quad. एक quad से हमको क्या मिलेगा बोलिए. So A bar plus B bar, A bar plus B bar, isn't it? Tell me. So इधर किधर होगा. Now you tell me now. Option C में नहीं ना, D में नहीं है. So we will eliminate now here. Here. So A and D. Next what else you tell me. What else? Any other quad I can do? Tell me. I can do this quad. I can do. Tell me. अगर A quad किया तो क्या आएगा यहाँ से. So this is given as B bar plus C. Where you can see the B bar plus C here. Here is there. Here is also there. Next what else the other quad I can do here. This quad is also there now here. Tell me what I will get now here. यहाँ से that is A bar plus C आएगा. You see this thing by combining कौन सा option satisfy होगा check करके बोलिए. Option A ना. Tell me. Option A सही बोलिए. Right. Next. Here tell me. POS form of a logic expression is most suitable for designing the logic gates using what? POS form. Which gate is suitable? Tell me. NOR gate is most suitable na. SOP form is NAND gate and POS form is NOR gate. Next. The sum of products form can be realized by using dash. SOP form na. SOP form I think we already done this thing here. NAND भी होगा and R. So option C na. Tell me. The maximum number of different boolean functions that can be implemented with a 4 variable. Tell me now maximum number of different boolean functions are how many? Tell me. Number of boolean function अभी हमने देखा ना formula. 2 power n is a number of boolean functions, isn't it? So tell me now कितना होगा. You tell me here. That is 2 power 4. So which is given as what will get now here. 2 power 16. So which is given as what we can say here, 2 power 10 into 2 power 6 we can write now. That means 2 power 10 means 1024. 1024 into what now here, 16. So kitna hoga? This is 65,536. This is only the expected number. You see big number here. So option D. Next, the number of switching function. Number of switching function, Boolean function, all are same. Number of Boolean functions. Number of Boolean functions, which is also equal to number of switching functions, which is also equal to number of switching functions. Right. So how many, tell me? What? It is? Oh, sorry. It is 64. No, sorry. Yeah, 2 power 6 now here. It is 64. Right. Fine. So which is equal to what we can say, 2 power 3. So how much this value, 2 power 8 now? How much the 2 power 8 value? That is 256. Isn't it? Right. Next. For the Boolean function f is given as the minimized product of sum. The minimized POS form they are asking. So what we can do here, if it is possible to simplify by using Boolean algebra, fine. If not, go for the K-map. So you tell me what we can do. Will you do the normal method or K-map chahiye boliye? So if you see the min terms are, this is 0 and this is 2 and this is 4 and this is 7 and this is 6. These are the min terms. So the baki will be the max terms, you tell me. Remaining are the max terms. Can you do this thing? K-map se hoga 1. Right. So K-map se karo. If I call, this is now here A and this is BC. Tell me now here A and this is A bar and this is B plus C. And this is B plus C bar and this is B bar plus C bar and this is B bar plus C. These are the min terms, right? So let's go for the max term. Say here 0, 1. 1 is a max term. 2, 3 is a max term. 4, 5 is a max term. 6, 7. Bas, itna hai na? Now let's group them here. I can do grouping this thing. By grouping this thing, what I will get, you tell me. B plus C bar aaya. Next. And by grouping these two here, क्या मिलेगा बोलिए ना इधर, यहाँ A group से, which is equal to A plus C bar. So you tell me the final logic expression, tell me here, which is given as A plus C bar into B plus C bar. So कौन सा option, tell me? A. Next, the Boolean function they given y given as like this. Now they are asking the minimizations. Try for the minimizations. So here direct minimization possible हुआ कि नहीं check करो. Tell me what I can do here. So if you see carefully what they has given in the option 1, so they kept this is as it is, remaining they simplified. Check for the remaining simplification possible hoga kya. I think we don't get this thing, right? So this is not the option. Yes. Now what we can do here, check for the options क्या होगा. Yes, now you see this thing, if I combine these two, then what I will get, to tell me? That is A bar B C D bar as it is. 1 and 3 मैंने combine किया, so what I will get now here? B bar C bar D आएगा, check करो, isn't it? Yes, next last one term is as it is, A B C bar D bar. Check this thing, that is exactly in option D, tell me. Isn't it? 1 and 3, केवल 1 and 3 हमने combine किया, बाकी as it is. Next, number of boolean function हमने कितनी बार किया, is a problem, tell me. How many number of boolean functions are possible, tell me. 2 power n, so which is given as 2 power 4, which is equal to 2 power 16. I think just now we did this thing. Now this is 2 power 10 into 2 power 4. So how much is value? 1024 into what you tell me now? Yes, this is 64. 246, now this one 64. So this is 65,536. Right. Tell me. They given the expression now here. This one will represent what? Yeah, you see this thing, they given this as all are max terms only. How many variables? 2 variables. So then what now is the output, to tell me? Which is equal to 0 hoga. Isn't it? All are max terms only na. All are max terms, so which is equal to 0. So कौन सा option, tell me? The output is independent of the inputs, isn't it? Output is independent of the inputs. Next. Yeah, same thing here. How many boolean variables? 4 boolean variables, 2 power 4. So how much we can say here? 2 power 16, which is given as 2 power 6 into 2 power 10, which is equal to 64, and this is a k na here, 64k. Next, tell me 160. Match the list 1 with the list 2 and select the correct answer using the codes given below. Now tell me the expression what we'll get if I match it. Yes, they are asking what now here? They are asking for the inverse. We need to find what now? Inverse we have to find, right? So if possible minimize, then find the inverse. So if you see this thing here, can I minimize this function? The minimized forms, if I combine these two here, so we'll get this as AB, BC and AC. Minimization. After the complement we should take it now, tell me. Complement we should take, so which will be given as, what I can say, this is A bar plus B bar into B bar plus C bar into A bar plus C bar, isn't it? Tell me. So इसका कौन suitable है, you say, check it now here. Yes, now if we see carefully in this, yes, now here and here, if we apply the T1, if we apply T1, tell me what I will get now here. This is A bar plus B bar C bar, isn't it? Into B bar plus C bar. 1 and 3 मैंने multiply किया. Again if we multiply, tell me what I will get here. This is A bar B bar plus A bar C bar plus B bar C bar plus B bar C bar. दो times repeated we can remove ना. So this is exactly second one ना here. 2 होगा this thing. Next. Now you tell me, is it possible to do minimize this thing? How we can write this one here? Tell me. This is A x nor B plus C bar. If I take the complement of this thing, so what I will get, you tell me? A x naught b bar de Morgan's law into C होगा ना. So this means which is nothing but A XR B into C. So कौन सा option, tell me? So which is equal to third one. Next A plus BC. So इसका complement, tell me now here. A plus BC bar, which is given as A bar into B bar plus C bar. So इसके लिए क्या 1. So obviously you can verify 2 3 1 2 3 1 किधर 2 3 1 4, maybe option B. Check करो. The output of the two-level under network is F. What is the output when all the gates are replaced by a NOT gate? ये problem हमने पहले भी किया. When all the gates are replaced, what will get now here? FD will come na, dual will come. Yesterday this problem, tell me all of you remembered. Yesterday we have did this problem. If all the gates are replaced by a NOT gate, it will become a dual. The number of boolean functions, अभी तो हमने किया ना by using 4 variable. कितनी बार repeat होगा ये problem देखो. Yes, now tell me now what is this thing here? In this case, how many NOT gates are present inside the loop, you tell me? How many NOT gates are present inside, you tell me, inside the feedback? We have a 2 NOT gates are present inside the feedback now. So what I should call now? This is a bistable circuit. This is what circuit? Bistable circuit. Fine. Yeah, this is given. It is a gate 2022. Tell me this thing here. Consider a boolean variable D where the output Y is related to input as like this. Now you see this thing here. They given Y is equal to A plus B bar. Y is equal to A plus B bar. First of all, you tell me now whether this is a functionally complete or not. Tell me now, is it is functionally complete or not? To identify the functionally complete, हमें क्या करना पड़ेगा? Check for this expression. Now if I place this as A is equal to 0 and if I place this as a B, what I will get now here? B bar मिलेगा. That means which we got this as a not. And this is Y is equal to, so what I am doing here, if I replace this thing as a comma B bar, if I replace, then I will get this thing as A plus B. Then this is what you tell me now here, OR gate. Then this is what I can call, this is a OR gate. Now you tell me now here. Now you tell me this is, so this is not is there, OR is there. So I can call this which is a functionally complete. Now tell me, which is a functionally complete. If it is a functionally complete, इसका मतलब क्या है? By using this we can able to implement all the logic functions. We can implement it now here. Tell me. So this is NAND is possible to implement, and OR is possible to implement, NOR is possible to implement, and AND is also possible to implement it or not. So this is all are possible to implement. This is the MSQ. Okay. Fine. Yeah, tell me now this problem. And then one last problem here, 165. This is a last problem in the logic gates. Now they given A minterms given, B minterms given. So we need to find the one by one minterms. You tell me now here. A minterms, they given the max terms of B given. So convert them into a minterm first of all. What are the minterms of B, you tell me? Which is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. These are the minterms, right? It also convert into minterms. So which is given as, tell me here. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So let's convert into min terms and let's start doing analysis. Okay, now you tell me now here, this is a NAND gate. You tell me if it is an AND gate, what I will get now here? Common things will come. But it is a NAND gate now, so क्या आएगा? Tell me. क्या आएगा? So here complement of common. What are common? You tell me first of all here. Which are common in the A and B here? 5 is common. 5, 6. 5 is common. 6 is common. Any other thing common? 11 common na, that's all. Yes, 11 common. So that means except this thing remaining will come. So what are the remaining? You tell me now. Bar. Why? Because not gate is there now. What is here? What I will get? You tell me. What are the min terms will come? You tell me now. Except this means what? 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Right, coming to the NOR gate, you see the inputs now A, B. So this is a NOR gate. NOR gate means some union. First of all, OR gate consider. If it is an OR gate, can you tell me what I will get here? A and B make common thing, all will come. So that is 0 comma 3 comma 5 comma 6 7 8 8 10 11 12 14. इसका bar will come. Why bar? Since it is a NOR gate na. Now you tell me what will come here. Except this thing remaining. So what are those? 0 is there. No 0 will come. Next what will come? You tell me. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 will come. Now all these are given. This is a inputs for this AND gate. These are the inputs for the AND gate. You tell me now here, AND gate outputs what will come? Common for this, all these things will come. Common things you tell me now. C. Yes, now you see common things now here. 0 0 no 0. So finally output ka min terms boliye, what will get here? 0 not there. 1 is there now. Here is 1 is there. Here also 1 is there. Here also 1 is there. So 1 will come. Yes, 2 here and here 2, here also 2. So 2 will come. Next what else you tell me? 3, no 3. 4, yes 4 4 4. Here also 4 is there. Next what else you tell me now here? 9 9, yes 9 is there. Here is there. Here also 9. Next what else you tell me? 10 no 10 no. 13 13 13 no 13. 14 14 you check it. No 14. 15, yes 15 is there. Here also 15, here also 15, here also 15 na? You see this thing, what is the option now here? 1 2 4 9 15. So option A, isn't it? All of you done? Done all of you? Yes. This and this is about the logic gates. हमने यहाँ तक हमने क्या किया? Logic gates तक हमने discuss किया. Fine. Now tell me now, shall we continue the K-maps and we'll do in the next class? आप ही बोलिए. Shall we continue the K-maps or we'll do in the next class? Fine. We'll do this K-map in the next class. Okay then. See you. Bye-bye. Good night.